We haven't yet talked about MJOs here in this lecture series, but podcast series, but I have MJO lectures in the Tropical Dynamics course and the S2S course, but we will touch on MJOs here and come back to it a little bit later on. We already mentioned it as the eastward propagating features that are dominant in the October to April period or the boreal winter season in general. Um, Here we are just wanting to understand if there is a relation between MJOs and the monsoon. So this idea of whether MJOs can happen in the boreal summer continues, and there have been nice papers by Bin Wang and Jones and a few people looking, Peter Webster and so on, looking at summer interseasonal oscillations and trying to see whether the so-called MJOs that we are talking about, northward propagating features, are part of the MJOs or they are independent of the MJOs. And the general conclusion of Jones and Bin Wang is that they are independent. So is there a relation then between the summer monsoon, which happens during the meso season, and the MJOs? This issue is complicated because MJOs here are basically eastward propagating intraseasonal features, and whether they start as eastward propagating features in the western Indian Ocean and then get detoured northward, or they are completely independent, is not a question that's answered yet. But this nice paper by Joseph et al., which is down here, looked at the monsoon season for 1975 to 2005 and did some nice analysis to look at the potential impact of eastward propagating features on the monsoon. And here the analysis is done by looking at the break periods in the monsoon. They split them into very long break periods, greater than 10 days, and medium, which are less than 10 days, and very short break periods, which are order 4 to 5 days. And the argument is that almost all dry years, deficit years, drought years are associated with very long breaks, longer than 10 days. Okay, so they start with that analysis result and look at the features. So we are looking at the OLR anomaly here in watts per meter squared associated with very long breaks. So you can see there is obviously a hot spot on India where you have the monsoon deficit, which is what we are focusing on. And there is this tilting structure again that we have talked about before, with a rainfall signal or a high OLR here. So sorry, low OLR. So high OLR is dry period and low OLR corresponds to deep convection cold cloud top temperatures. So that's the rainy part here. So this also makes sense in terms of the feature we saw of the north-south pattern when we looked at the OLR for the 10 to 20 day and 30 to 60 day band before, right? And this is the feature of OLR anomalies in the very short break period. So you can see that this is very local, doesn't have this large-scale connection, which, if you know El Nino and Indian Ocean dipole and so on, you may begin to get a sense that maybe there is a relation to forcing from the Pacific, but it's not obviously that simple either. Just to complete the story, this is the propagation characteristics of a typical very long period, very long break time longitude plot of OLR anomalies here, averaged between 5 south, 5 north, so deep tropics, and B is the same as this one, but for averaged over 10 degree north to 25 degree north, so over the Indian subcontinent. And C is time longitude time latitude plot of composite OLR anomalies averaged over 70 to 90 degree east, so you can see the northward propagation. So here you have deep tropical eastward propagation that is fairly clear. Again, we are going from lag minus 30 to lag 30, again day 0 being the peak dry or maximum OLR on the Indian subcontinent. So you have the eastward propagation in the deep tropics and the westward propagation in the Indian subcontinent. So we have seen this in the 10 to 20 day kind of time period as well, and they are originating here in the far western Pacific or western Pacific maritime continent and propagating over to the Bay of Bengal and Indian region. And there is a northward propagation as well. You can see here starting at day minus 10 on to day 10 here. So that's starting also in the deep tropics and propagating northward. Okay, so obviously you can also look at this for the very short break, and you can see the structures are not that coherent as in this case of very long breaks. Okay, the long story short, this paper basically argues that there are Rossby waves that are probably originating in the Pacific Ocean, most likely related to El Nino, either in the eastern Pacific or around the dateline, and those Rossby waves are able to generate subsidence and very long break periods over India, leading to droughts. Okay, I'll make another point in the next plot when it comes to this Rossby wave story. So this is the power of symmetric OLR spectrum averaged over the period of 30 to 60 days for winter, summer, drought, and flood. Here the symmetric can mean zonally symmetric or meridionally symmetric, but we are looking at the equatorial signal, so the Rossby wave kind of signature. So here the boreal winter, summer for drought and flood years. So in the boreal winter, eastward propagating signature dominates in these wave numbers, especially in the wave number 1 to 4. And in the summer, you can see that the energy is there both in the eastward and westward propagating wave signatures, but the difference is not that great, even though in waves number 3 and 4 westward propagation is dominating here. Okay, so that corresponds to these features we looked at here. For droughts, we are seeing many more eastward, much more energy in the eastward propagating, but also some energy in the westward propagating, whereas in the flood years, maybe westward propagating are overall more dominant, but mostly the energy is both in eastward and westward propagating waves. Okay, so obviously Kelvin waves and Rossby waves are what we are talking about just in terms of wave number spectra. So the story is that maybe MJOs have a relation with the monsoon, especially during dry years with these very long break periods which have coherent eastward propagating signatures with westward propagating Rossby waves arriving over the Indian subcontinent. The story is a little bit more complicated maybe when you look at the overall droughts and floods over India, and this is the long time series. The blue and green here are normal or excess years, so you cross certain rainfall thresholds, 10% of plus minus 10%, then you declare them as droughts, otherwise they are considered normal. But what you can see is not all floods are associated with the monsoon. There are many floods which are not all floods are associated with La Nina. There are many years where there are very strong wet years or floods that are not related to El Nino, and similarly there are lots of years where El Nino happens but it's not an official drought, or there is an official drought but it's not an El Nino year. Okay, what does that mean? Basically, if you think about the seasons of MJO going from October to April, mesos going from, let's say, May to September, the MJOs, or at least eastward propagating features and westerly wind bursts over the western Pacific, are often associated with El Niños. That's a separate question, but I will still mention that. So the question is, are there more eastward propagating features during an El Nino, and that is what relates El Nino to monsoon droughts? If so, what about the other 50% or so of the drought years that are not associated with El Ninos? Are they still associated with very long breaks, and are there still Rossby waves coming from the east? If so, how are they forced? Obviously, it's possible that the West Pacific convection, which is a massive heat source, jiggles and produces Rossby waves without resulting in an El Nino, or there are lots of these so-called dateline warming or Central Pacific El Ninos, which send Rossby waves and cause droughts, but they are not always counted as officially El Ninos. Nonetheless, sticking to intraseasonal timescales, there is interaction between interannual and intraseasonal variabilities, and eastward propagating MJOs and westward propagating Rossby waves and monsoon droughts. But this is still something that obviously has many open questions as usual. But as I said, these are challenges, not limitations, so you can pursue those as research topics. Okay. I forgot to turn on the light on this side, which would have made the light better, but I'm not focusing so much on the aesthetics of the setting in these podcasts, as you already know.